Hello everyone. So everyone can hear me?
Yes, Manas, we can hear you.
That's great. So we'll be starting within 2-3 minutes. We are just waiting for a few more people to join. And we have Abdul with us. In the meantime, Abdul, can you give a short introduction about yourself?
Hi, team. Makeathon Day. I'm a designer by profession, and I hope all you guys are working on it. To explain more about me, I've been also using Workbench project and all their rapid prototyping tools, so I can give you a and how you can develop your product towards production. Right?
Okay, thanks a lot, Abdul, for that. Yeah, so we are just starting. We will also be having Andrina and Tarun joining us in a while.
Hi everyone, I'm already here, Manas.
Oh, hi, Andrina.
Great. I wondered, could everyone hear Abdul well? Because for me it was not a good connection. What was the other's experience?
Yeah, we can hear you.
Okay, so for me I could hardly understand Abdul. I don't know what could improve this. Maybe talk closer to the mic if that works.
Oh, can you hear me?
Meanwhile, I'll request others to please mute their mic.
Can you hear me now?
Yes, I do. Before it was breaking and very hard to understand.
Okay, okay.
Okay, I'll let you moderate, Manas. I'll just be listening.
Sure, Andrea. Yeah, so Abdul, if it's all set, we can start right now. We almost have we have few people who have already joined us.
Okay. Okay. Manas?
Yeah, Abdul. Yeah, so you can start from your side.
Okay, fine. So, in the process of this set of webinars, you have been introduced to design thinking and one past 2 to 3 weeks of time of design thinking, and sadly we hope at this time you guys visualizing your product. So I hope this webinar is going to help you in most of the due respect. What is rapid prototyping? It's what I would like to put you across first. Rapid prototyping is a process whereby you actually to reality by various methods which is available as tools, either devices or your basic mechanical method or a clay molding system. Every idea as you evolve, you would have developed a basic sketch. That is the first stage, and you right. So that is the first stage to make yourself clear that you're going towards a rapid prototyping method. And when you're doing a rapid, how you can approach it. One is by building it from a scrap, or even a paper mash could be used to build a simple under clay of the form. So form analysis could be done after you have finalized the basic idea and the detail and the look and feel of it. You convert them into three-dimensional drawings. Either you or scanning basic model that you have done and then take it into a 3D printing version with other free software, open softwares that are available to develop a 3D model like 123 CAD is a very good developing software, so which can interface with your 3D printing devices. So my introduction to rapid prototyping is that now have a fair idea of about your product and you are in the stage of developing CAD drawings and 3D files, can go on to using 3D printers as your printing devices. So that is one way of looking. Okay, this is not going is the direction that I'm going to work on. So then you could look at into doing it manually, like or any other equivalent to wood, like laminated sheets, paper cuts, also could be used to make your prototype. So rapid prototyping basically helps you in production system. Like before you're going to mass production, you need to do a rapid prototype or a prototype that works. Test the load factor that is applicable. If in case of a knee joint, you need to understand what's the kind that and what is the locking systems required for it and what is the kind of material analysis you need to do. So today 3D model. I hope that is the stage that you guys are today. So you and analyze your product or your 3D model on FE methods, finite element methods, and and then you could actually also take it to your rapid prototyping phase by 3D printers. So I would give a rough introduction to 3D printing. 3D printing basically it's a device which is like printing devices are available today. They can understand your STL file. Basically, you can export your and send these STL files to your printing machines, which would be then printing out the product in a the 3D printing process. If you want furthermore helps, probably we could give you much more detailed, in-depth knowledge. And if you are working on a mobility, you might have to work on the RPMs of the motor, the hub motor, all this specific on the load factors. And I think to all this, you should have completed by now a complete the person touching the product and getting out of the product. How he is going to touch the product, how he is going to use the product on the road, on the street, how is it, or inside the house, wherever is your use case, you should have actually the details to accommodate the product. Hopefully, I think you guys are in that level. So to make your product into multiple components, and these components could be so now Hello?
Yeah, Abdul, we can hear you.
So, are you guys clear? Because I want to take it in stages. Prototyping cannot be explained in one shot.
Sure. So you would like to have question answers in between this session or at the end?
No, I think because each team has to communicate whether they want a 3D or what is that they are actually looking forward, so that I can give an on-hand experience and support them in taking that to their level.
Definitely.
It's a process where people can realize their product. What is the product that they are working on? If they could discuss with me, printing, or to go with the mechanical method, or to go with any other substitutes.
Okay, so in that case, I guess Rina is there. Hello?
I guess she's on mute right now.
Okay.
Yeah, so Abdul, so we'll ask the teams regarding their projects, and then you can discuss further.
Yes.
Okay, so any of the team members, would you like to tell Abdul about your project and take this conversation further?
Yeah, I think we can start one team at a time. So who is currently on to use some of the facilities like 3D printing or any other like laser cutting devices that they want to use to develop their prototyping
Okay, so
and help them.
yeah, so I'll suggest Nekram. Can you start?
Yeah, okay. So I don't really need, I don't know what I need, but if you can see my device, this splint sort of for hand,
Okay.
and my idea is to work with the paralyzed hand below elbow. So at that I got a elbow range, but they don't have any function below elbow, but the hand is there. There's no amputated.
Okay.
So how they can do the activities like typing or writing or feeding, brushing, and all those activities with using some support. So
Okay.
what I did, I made like this. You can see, so they can have support like this, and through this could be fixed,
Okay.
and then they can use this finger
Okay.
as a pointer. So I'm just resting these three fingers up and down, and this finger could be used as a pointer and typing on a.
Okay.
So this is just made out of low temperature plastic with molded with a heat gun or boiled water, and this is a plastic which could be melted on a certain degree of temperature and then just quickly it gets hard.
Yes.
So this is the material I'm going to use, and I've designed few of them like this. So some of them they have this range, but there's no fine movement in the finger. So like this part of it. So
Okay.
these are things I made, but I don't know what tool I'm going to use to make it a final prototype. But I'm still looking for design.
Yeah, I understood fairly about what you're trying to say. Rapid prototyping is exactly what you have done. The process of using heating and
Yeah, heat gun, and then or maybe boiled water.
yes, you have used a
Yeah.
similar process which is recommended in prototyping, rapid prototyping to develop.
No, I don't. Uh,
Hello.
yeah, so I just want to ask how to go forward after this and to prototype it. So
This, that is a user activity analysis now you have to do to
so I
understand
yeah,
whether
yeah, yeah.
it is functional in all days.
So I have done the trial on 4 subjects, and they are able to use it. They are functioning well,
Mhm.
and so it's working perfectly fine with this design. But this is a crappy design. I want to make it very much look good and cosmetically good.
Yes.
and how it could be adjusted to different users without customizing it. So what standard design could be made in a way so that every person can just have it. So it's like that.
Yes, that's exactly what I'm trying to say. User activity can help you identify multi-functions that this product has to do, depending on
Every person can just have it. It's like this also.
that is also exactly what I'm trying to say. How user activity
Shaju, can you mute your
Saju, can you
Saju,
please?
can you mute your microphone, Saju?
Yes, there are some problems related to the connection.
Okay, okay.
Okay.
I'll be moderating it, so you
Okay,
guys can
Nikram.
continue.
Okay, Nikram, I've understood what you're trying to develop. So,
Okay. Yeah.
try to analyze your product now on use, put it to
Okay.
use, and record as a video, and try
Okay.
and understand what other uses it can
Okay.
do. Right?
Okay. Okay.
Based
Okay.
on that, you might have based on that you might have to add soft surfaces or hard surfaces where
Mm-hmm. Okay.
you could use as a cosmetic treatment by
Mm-hmm.
bringing in other materials to it, which could be a
Okay.
clip-on system. So that
Uh-huh.
also you can develop using, but aesthetically it looks nice.
Okay. Okay. So for example, you're saying like this. This is a pointer, and this is like a
Yes.
clip-on system which you can clip it like that. You're saying? So it's like that. This is
You
yeah.
can use on your basic model, you can use clay addition,
Okay.
layers of
Okay.
addition
Uh-huh.
to aesthetic component of the product, right? And how
Mm-hmm.
when it is removed, where it is placed, how it could be accessed,
Okay. Okay.
or how are you going to access all this, right? Packaging of the product, all that
Mm-hmm.
you can think in terms.
Okay. 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 Yeah, I got your point.
To develop your idea. So
Uh-huh.
that is one stage. Now, if you want to cosmetically treat it, probably
Yeah.
I recommend one more apply layers of different materials
Mm-hmm.
depending upon the functions that you need to address. If it is for gripping, you can go for foam, or if it's for
Yeah.
so this is something you can add on and also bring in color to the material. So
Yeah,
that
I'm going. Yeah, because all four the patients of mine they said it's good, it's functionally well, but the cosmetically is not good.
yes, fine. I think
So
there's a good scope there to develop. Probably
yeah.
to analyze and record them in detail
Okay. Okay.
to say whether it is actually addressing all the issues that you want to address.
Okay. Okay. I'll do that. Yeah.
Anyone else?
Thank you.
Anyone else who can show their model to Abdul?
So, anything from your side, Ganesh? Any question regarding your product?
Hi. We are not at manufacturing stage right now. We are modeling things and doing FEA sort of things. So we have not started manufacturing, but we don't need 3D printing or something. We need facilities where we can use CNC milling or something like that.
Yes.
And we want to fabricate one KFO device in APD, and probably we would like to do that during next week during Maker Days. So my question is my question is about regarding Maker Days. Can we is it possible for us to make few things using CNC machining machines available at workbench projects or these things?
No, I think we have CNC routers which can work only on wood and laminate.
Okay.
So that I think you can access it, but probably it would be charged on the material, and so that is up to you guys to have a discussion.
Okay. We need
But
to.
surely we have. Surely we have an access to CNC router, but not on metal.
Okay, okay, fine.
So I think Abdul, you can move ahead now.
Yes, yes. Saju?
Shaju, can you hear us? Dinah, do you have any questions from your side?
So I don't have, can you hear me, first of all?
Yeah, we can.
Okay. I don't have the model of the device here, but it's hard to think about maybe if there are any suggestions on how to rapid prototype something that's pretty large. So the device that we're building is to help bilateral upper limb amputees get dressed in the morning. So the amputations would be above the elbow. And the device is currently about the size of the person. It's like an upside down U bracket, and it uses foot-powered pedals to clamp down on the clothing so that the person can load the clothing independently and also put the clothing on. But so far we've been building out of wood. We actually have access to 3D printers here, but everything that we're using is too big, so I don't know if there are any suggestions on, quick and easy ideas on how to build new iterations of design without, doing something big.
Yeah. With that material and you are not able to access 3D printers or any other rapid prototyping technology, I think wood is probably you can use soft wood like a plyth or some of those soft woods, so that you can easily carve them out to the form and to your arm or to your knee. So that is one way of looking at it. Or I would even suggest the Korean material or the soft acrylic, like what bended material. It's like your sheet of plastic, which on heat bend takes a shape, and then it rests on. See, rapid prototyping is basically to realize your form that you are going to build and overcome your production. So break your prototype into components so that your joints could be made with harder material, and the rest of the form is actually made with a slightly softer material. So it doesn't hurt anyone when they are being clipped or used. So that is one way of looking at it. Or you could even, if in layers, you could build the whole prototype in layers, multiple layers. It's like multiple layers of printing, layers from the paper. Probably that also could help you realizing how things can be gripped on or could be as they are moving.
Okay.
Okay, Abdul. So I guess we can move ahead now.
Yeah.
Is there Mohammed? Can you hear us? Any questions from your side regarding prototyping?
Hello, you hear me?
Yeah.
Yeah, definitely we can hear.
Okay. So basically, my question is not about probably not about prototyping, but moving from prototyping to the next step. And what we have here, probably some of your guys already saw, is the prototype of a hand that we are trying to basically move from prototyping to the next step. And we have basically this modular design that the finger parts will be inserted to the palm of the hand, and this palm of the hand should be done basically in the local where the patient is. So imagine we have a standard module for the fingers that will be inserted here. And so the question is, when this goes to the patient, this part, which is basically the palm, is patient specific. And I have seen basically tutorials from ICRC about lower limb prosthesis that is done in places locally with the propylene, with heating the propylene. And I was thinking, my question is, do you think it's possible to develop something like this locally, patient-specific, so that we can insert our standard module on that?
Yeah, I would like to recommend you that is, you should look into biomimicry. Biomimicry is the method where you could look in how the you turn. That is also a way where you can look in. There are quite a concepts that are being developed in biomimicry. If you want it to be more user patient will have a different proportion. This folding methods of biomimicry can actually be helpful to you. Probably you should look in. You can get more ideas about the finger counts, because each finger has a different length depending upon the body. This proportion is but in nature there is a very easy way of handling it, and biomimicry talks about it.
Sorry, I'm not hearing you very well. So what you are referring to is biomimicry?
Yeah, biomimicry is
okay.
Which says there is it's like more like understanding how flowers, for example, grow in different proportions, but still they are into an algorithm called phyllotaxy. So do a pattern, which is very specific to every person. So this is very well dealt in biomimicry, and there are a lot of people a personal proportion to each prosthesis that you are actually developing. So, your joints should be so adjustable by the flexibility of the material.
So basically, we have the flexible material. So our hands, our fingers are flexible, and is we use kind of soft mechanism for that. My question is basically, when it goes to the patient, we have this part which is a standard, and then we have this part which should be done in the local.
Okay.
And my question is, what are the ways? I mean, what do you think about rapid prototyping of that in a hospital or in places that ICRC basically puts the system to the hand of the patient?
I'm also not aware of what is the facilities available with the ICRC, but if you want to take that into local production, folded sheet metal, that's a very easy way of bringing in only that component, the arm component. Sheet folding method is the easiest way to bring in the arm component. If I'm right?
I have some difficulty hearing you actually.
Yeah, exactly. I'm also having some difficulty.
It's just I think a couple of people are talking at the same time, so it's not possible to.
Is it okay right now? I'm trying to make it better, but yeah, there is a bit of problem.
Can you hear me now?
Yes, I can. It's the best thing is to mute the microphone of everybody.
Yeah,
so
I'll again everyone to mute the microphone when two people talk.
Yeah. Okay. Now I'm not aware of what is the facility available with the ICRC. Only the palm locally built. I would suggest sheet folding method. That's a very easy and
Sheet folding.
Yeah, sheet folding. It could be a metal sheet folding, and a cost-effective way that you could apply to build your arm, the palm area.
Okay, thank you very much.
So I guess you can move ahead with your webinar, Abdul.
Yes. So now process that helps you realize building your product. So there are a couple of methods, not only couple, I think quite a few methods. Fold process to which is applied to a plastic material to take the shape. So that is one method. There is 3D printing. There is and you've got the sheet folding methods, which is also a cost-effective method and can help you with very less weight. There are also methods which could be used by using bamboo, cane. These are all very cost-effective to realizing the product. These are all methods to just visualize and understand how the product is going to be. But you to use the right material, then probably CNC routers, which can help you build the joints. That is also a way. What we are looking into in this whole webinar is to say that rapid prototyping is an approach to build your product way, and to say whether it works, it fits or solves your problem, and then rethink your design if it does. Otherwise, like Neckham has actually applied it. You could improvise your product. So prototyping, rapid prototyping helps you. When it comes to developing, it is very specific. Every product has a very specific approach, which is something like form in a sheet fold method. But if it's a form-based method, probably you might have to go for a clay molding or like a rapid cold and methods. So this is all that you could apply to. But if you want to use workbench project, I think we have quite a few of them. CNC routers, and you can use your laser cutting devices. That part we can help you out in getting your hello. So now to be very specific, actually are clear on what is their product is going to be and what is the kind of activities that they are going to address to and how it is going to community. Now this activity analysis that we are stressing upon is very important. So to iterate your product, this process of activity analysis can help you improvise the product. Rapid prototyping is a process model and see whether it works or not. But after that, how do you analyze? How do you say that this is going to? It's only by a thorough understanding of the user activity analysis has to be done. After the prototyping product that you have done, you could actually put it on them and say, now use the product. Let us record your or using it. Then you again go to the next stage of improving the product. You can, this prototyping is a process only to improve the product. It touches the mass production. So I leave it on this note saying that prototyping can help you in the product and also testing your product. Yeah. So now, if these three rapid prototyping into developing your product and test it. So those who have access to do your model, like any other guys have done, and very specific to the teams which are working on hard materials, CNC routing machines should be the right rapid prototyping tools for you guys. So I think this should be a fair introduction to rapid prototyping, Manas. To all the help that they want or any questions that they want.
Maybe we can't make it like this.
Yes.
Hello.
Because they don't have that.
Hello.
Hello. Yeah.
Uh, hello.
Hello. Yes.
Yeah, Shaju, we can hear you. Continue.
Yes, it is not clear here, so I am asking again. Okay, thank you. We are searching for some of the materials newer to create new prototype, but there was a problem. Some of the materials are not available here for some functions, attachments. So, can we get any support from there to make such components?
Yeah, sure. Are you willing to build them in 3D print?
Oh, in any model we will like to do. It is to be a good model.
Yeah, I think 3D print
Hello.
will be possible here, Shaju.
Okay, okay. Then we have already one type of prototype we firstly made, and another we have to change to another design. Some of the design changes are to be done there, and we think that in the maker days we will get the help.
Yeah, I think it should be
Hello.
possible here, Shaju.
Definitely.
Yes, yes.
Yeah.
Okay, okay.
You might have to basically just get in touch with the Workbench project team, share them with the idea that you want to develop, particularly
Uh-huh.
on the drawing, the size and the dimensions,
Okay, everything that
and
measurement to be given to you.
yeah, measurements to be given, so the CAD files could be generated, and then printing can be taken.
Okay, okay.
A market which you like a ball bearing or something that you are looking in.
Uh-huh.
So you can share them with that. So if there is a and rescale it and print it for you.
Okay.
Any further questions from anyone at this point?
Manas, I think we are done here, Manas. I think I've covered it rapidly on the basically on your 3D printing or laser cut.
Sure, sure, definitely. I think so. Nikram is about to ask something, is it?
Yeah, yeah. So I just wanted to ask to like if I would like to use the 3D printing to improvise the design, is it possible to have a I mean,
Very much. Even if you are not able to use the 3D printing, probably developing
file?
cam files, right?
Mm-hmm.
So yes, you can use that as your base rather than
Okay.
spending them develop it in the software and try giving different colors or shape. Then probably you can choose the right one and then.
Yeah, I got your point. Thank you.
So any further questions? Deepu, Diana, Mohammed?
No, I'm okay. Thank you.
Thanks. Uh, Anything, Ganesh?
No, we are fine with this thing.
Okay, so I think so we are done with the today's webinar too soon, covering all the points.
Uh, just one thing.
Yeah.
Uh, which all materials you can 3D print in your facilities? Only ABS?
Yeah, only ABS and PLA.
PLA, okay, fine. Okay, fine.
Right?
Yeah, thank you.
Can I just add that there's one more webinar tonight happening? It's at 8:30 Universal Standard Time, which is 2 a.m. in India, just in case if that works for any one of you. Or you're welcome to watch it on YouTube later.
Thanks, Andrina, for that. So yeah, at 2 a.m. we are having Paul with us, who runs a makerspace in Geneva. And I think we are done for this, so we can wind up. Thanks a lot for joining us, everyone.
Yeah. Thank you, guys.
Thank you.
And in case you guys have any other questions regarding any doubts, you can just email it to Abdul.
Yes.
We'll provide you his email ID, or you can just email it to me. I'll connect you guys with Abdul.
Okay, thank you.
Thanks a lot, Nikram.
Okay, thank you everyone.
Thanks. It was very nice.
Thanks, Sharwari. Thanks, Abdul.
Thank you.